Okay, we're going to look at something a little bit complex initially. So we're going to factor involving fractional and negative exponents. So I've written down a few things that I think you should keep in mind when you do these. One is, just like before, we're going to find the greatest common factor. The second one is kind of a newer type of rule, but you're going to use the smaller exponent in the two terms. And I'll show you what that means in a moment. And the third thing is, it just reminds you to remember your rules for negative exponents and fractional exponents. So if we look at this example, we can already see that there's greatest common factor is x plus 1. Now, we're going to use negative 3/4 as our exponent, and I'll show you why in a minute. So we're going to use that, and we're going to multiply that by x, and the other one is still x plus 1. That's going to be the greatest common factor, 3/4. Now, to get 1/4 when we multiply these, we will multiply this by x plus 1 to the 4/4. Because if you remember your rules, negative 3/4 plus 4/4 is 1/4. So that is the reason why I say use the smaller exponent in the two terms. The smaller exponent in this case was negative 3/4. So now we have a little bit of work to do here. We're going to take our greatest common factor and do just like we've done before. We're going to simplify, which we did, and we're going to use that rule of finding the greatest common factor and grouping. So here's what I mean by simplifying. We have the same thing here. Can't really simplify that too much yet. And that's times x. That's our first term. Plus, now this is x plus 1 to negative 3/4. But we know what this is. X plus 1 to the 4/4 is really like times x plus 1. So by grouping, what we can do is we can say, all right, we have x plus 1 to the negative 3/4. And then the other term, I'm going to use square brackets, is this x plus this x plus 1. So it's just like we've done with the other ones. We factored out the greatest common factor, all of that, and then we use the other two terms for a second product. So what we really have is we have a times b. Now, something about the negative exponents we should remember is that negative 3/4 is the same as putting x plus 1 to the positive 3/4 in the denominator. And this is still to the power of 1, so that's going to stay in the numerator, but we can simplify it. 2x plus 1. So for now, that is how we do an example like that one. Let's look at a different one. This one's also from the book. So if I start with x times x minus 1 to the negative 1/2, and then I have plus x plus the quantity x minus 1 to the positive 1/2. Okay, we should be able to see that we have already a greatest common factor. So our greatest common factor, we're going to use the smaller term, negative 1/2. So the first one is just times x. All I did was switch positions. Now plus, well, we have to write this one. Well, if that's the greatest common factor. The greatest common factor is so you have x minus 1 to the negative 1/2. Now, what do we multiply that by so we can get x minus 1 to the first? Well, that's x minus 1 to 2/2. Now we can take this, and we've got greatest common factor, factor in both. We have x minus 1 to the negative 1/2 times x plus, same thing. Now that's the first, so this is just x minus 1. When we simplify that, we get x minus 1 to the negative 1/2. Now we're by grouping, times x, this x, plus this other term, x minus 1. Remember what we do with negative exponents? So that term ends up in the denominator as 1/2. And the top, we can simplify to 2x minus 1. Now we can leave it like that, or we can say 2x minus 1 all over. Well, you know what the 1/2 power is. The root of x minus 1. And then we'll get into rationalizing the denominator again.